So our next speaker is here, Professor Abhijnan Chakraborty. And so let me introduce Abhijnan. So Abhijnan Chakraborty is an assistant professor at Indian Institute of Technology, IIT Delhi. His research interests fall under the broad theme of computing and society, covering the research areas of social computing, information retrieval, and fairness in ML. So prior to joining IIT Delhi, he spent 2.5 years at Max Planck Institute of Software Systems, Germany, as a postdoctoral researcher, and he obtained his PhD from IIT Kharagpur, where he was awarded Google India PhD Fellowship and Prime Minister's Fellowship for postdoctoral research. So prior to joining PhD, he spent 2 years at Microsoft Research, working in the area of mobile systems. So he has authored several papers in top-tier computer science conferences that include WWW, KDD, AAAI, AMAS, CSCW, ICWSM, and Mobicom. His research works have won Best Paper Awards at ASSONAM 16 and Best Paper Award at ECIR 19. And he is one of the recipient of an internationally competitive research grant from Data Transparency Lab to advance his research on fairness and transparency in algorithmic systems. Yeah. So yeah, thanks, Abhijnan, and maybe you can take over. Thanks.
Yeah, thanks a lot, Mayank, for the kind introduction, and also for to all the organizers for inviting me to talk in this workshop. Let me try to share my screen. So just let me know whether it's visible.
Yes, it is visible. Yeah.
Okay. And am I audible properly?
Yeah. Yeah.
Okay. Thanks. Yeah. Good morning to everyone who is joining from India, and good afternoon or evening to others joining from other time zones. So in this talk, I'm going to present our work on fair partitioning of public resources, redrawing district boundary to minimize spatial inequality in school funding. I am a faculty member at IIT Delhi. I'm Abhijnan, and this is a joint work with Nuno Mota, Negar Mohammadi, Palash De, and Krishna Gummadi. So this work appeared in the web conference earlier this year. So in this talk, I'm going to focus on fairness in grouping. So most research works in fairness in machine learning, including the works you have heard today morning, they consider the groups which are socially salient. So that means that where the groups are formed by different users or different individuals' immutable sensitive attributes, such as groups based on gender, race, religion, and so on. However, in reality, a population is often grouped regardless of their sensitive attributes. So, for example, we divide the city residents into municipal wards. We don't look at like who is a we don't look at the gender or the race when determining this municipal wards, right? We group voters into electoral constituencies, or even in online platforms. We cluster a group users into different user clusters where the sensitive attributes may or may not have been used. Now, one important thing is that in such situations, people belonging to a particular group or cluster, they share the same fate. And this is an important thing. So your group membership determines how good or badly treated you are by the platform or by the entity, a particular entity. And this particular issue, that is fairness in group membership, it becomes even more pronounced when it considers the distribution of public good or resources. So in this talk, I'm going to focus on one specific instances of such cases, and this is about public school funding. So in the US, public schools are widely accessible, and they offer tuition-free access to all the students belonging to different race, gender, different economic background, and so on. Now, these public schools are grouped into different school districts for better management, administrative purposes. And in fact, the funding for these public schools, they come mainly from the government sources. And there are like three kind of sources. I'll just talk about that in a moment. So the key question which we are interested in is how is the per student funding distributed across school districts, since our goal is to look at the fairness in distribution of this public funding or public good, right? So to answer these questions, we gather data on school district revenues, their strength, like how many students are there in different school districts, and school attendance zone boundaries. So every school has an attendance zone from which the students can enter the school. And we also look at the poverty level of the students as determined from how many students can get like free lunch or reduced fee lunch in the schools. In fact, to compare this data across different school districts in different states in the US, we also normalize this funding information using teacher wage index. So essentially, it gives us a way to compare school revenues or school funding across different states without caring too much about like what is the living wage or what is the living cost in those states, because that is being handled by this normalizing factor, which is the teacher wage index. Now, in fact, if we look at the school funding scenario, the government funding comes from like three different sources. So one is the federal source, that is what the federal government gives. Then there is another component from the state sources, and then from the local government sources. So this local government sources includes the like the city council, the local county government, and so on. So when we look at the federal and state government in the left hand side, we can see that as the number of students from poor families increase in a school district, the federal and state government funding also increases proportionately. So in some sense, the federal and state government funding goes to schools where more poorer students study. However, when we look at the local government funding, it's exactly the opposite. So in fact, like more funding goes to schools where more wealthy people are there. And the main reason is that there is a correlation between the local government funding or the funding which the local government provides and the property taxes they can raise from people who are living in that area. So in areas where the property prices are high, those areas, typically wealthy neighborhoods, there the funding which the local schools get is much higher compared to schools where there is, schools in a poor neighborhoods. However, this particular funding source outweighs all other sources, and as a result, when we look at the total funding which goes into different schools, and in fact here we are talking about the total funding per students, we can see a clear correlation between the wealth and the funding different schools get. So in effect, the poor students get much less funding compared to wealthy students. Now, in a different work, which was carried by a non-profit organization, EdBuild, which looked at also the racial aspects of the students, they found that non-white school districts get $23 billion less yearly than white districts, despite serving the same number of students. So there is a clear gap between the between the amount of funding different school districts get based on either their financial conditions, or even there is also a racial correlations to that. Now, the next question we were interested in is to look at how is the funding distributed within and across different states, how different states are doing. So if we look at this, so this is actually different box plots showing the range of funding which goes into different schools, different school districts. We can see that even when we compare the median funding, so and which is denoted by this red bars in all these box plots, we can see that in states like Alaska, New York, or Wyoming, the median funding per student is much higher compared to states in Alabama, Mississippi, North Carolina. So in these states, even the median funding which different school districts get is much lower than their counterparts in other states. And not only that, when we look at the range, that means the variance within different states, even that is quite high. So for example, in case of New Mexico and North Dakota, you can see the range. Like some school districts are funded quite highly, and some school districts are funded quite poorly. Now, one important thing which we consider in this work is that, okay, I mean, we get that different school districts are funded differently, and some school districts are funded well, and some districts are not funded that well. But how far are these school districts from each other? Because if they're very far, it may not matter. But if they're close to each other, then it clearly shows us like a very stark contrast, right? So let's just look at one example. So this is a school district, Greenport Union Free School Districts in New York. Now this is surrounded by 3 other school districts: Sullivan West, Deposit Central, and Downsville Center school districts. Now, if you look at the numbers which are shown in the parenthesis, so this is the per student funding this school districts get, and you can see clearly that while Greenport Union Free School Districts get only about $19,000 per student per year, its immediate neighbor Sullivan West Center school districts, here the amount of funding, amount of per student funding is almost close to 60,000. So there is a clear and huge gap. And in fact, it's the same even in Deposit Center school districts, where it is close to 37,000, and Downsville it's 30,000. So there is a clear difference between even neighboring districts. Now, here we touch upon an important concept in this inequality, or the distribution being unequal. So if we look at, or if we try to understand the perceptions of inequality, that means like how people perceive these different inequalities, there has been some psychological studies which showed that people's perceptions of inequality actually depend on their social positions, as individuals typically do not observe the entire income distribution. So in fact, they often rely on cues from the local environment to guess the overall distributions of income, and then try to identify their place in those distributions. So in other words, let's say a person living in a village in India, that person may not care about how much Mukesh Ambani or Gautam Adani is earning, but they may care more if some people in the village are earning much more than what they can earn, right? So in some sense, the kind of envy or the kind of perceptions of how unequal different benefits are, it is manifested by their position and the local environment, like the place where they live, etc. So in this context, we propose a new notion of inequality, and which we call spatial inequality. So spatial inequality actually captures this inequality perception, where we compare the treatment among neighborhoods rather than we compare across the whole population and then say like which is more equal or unequal. In fact, in order to make this particular concept work, of this concept of spatial inequality, we need not have a specific geographical context, and it can be applied for various notions of neighborhood. So we can think about in an online setting, neighborhood means like people who share similar features or whose features are close to each other. But of course, like it has more direct application in cases where there is also a geographical neighborhood. Now, so let us try to define what is spatial inequality. So there has been a lot of works in inequality indices in the past, where people look at the income distribution in the population. So let's say that here I am showing like 6 different individuals and the amount of money they earn. One popular index is inequality index is known as Gini index, which essentially look at all individuals in the population and try to identify the difference between how much a particular person earns against the income of all others. And then there is a normalization factor. So essentially, we look at each individual user or each individual person and compare with all other persons and calculate the difference in income. And this we do for everyone. And then we kind of normalize to arrive at a particular index value. And the ideal setup is if the income is distributed, let's say if the government mandates that rich people should pay a lot more taxes and this tax money directly goes into the account of the poorer people, then we would arrive at a situation where more or less everyone gets similar income or their earnings are the same, and that would lead to the lowest possible inequality. So that's the basic idea of inequality indices. Now, how is spatial inequality index different? So the difference is that instead of comparing between every individual in the society, we look at people's social network or social neighborhood. So essentially, let's say that this is the social network, like one person is connected to other people and it kind of forms a particular. So let's say that here is a cluster, here is another cluster, and we are just going to compare between these clusters rather than comparing with everyone. So essentially, we define spatial inequality index such that where, of course, we normalize with respect to all individuals in the population, but then within that, instead of comparing against everyone, we calculate the difference within neighborhood. So essentially, for this particular person, we only compare with like her income with the income of these two other individuals. Similarly, for this person, we compare with his neighbors, and we continue to do it to arrive at a number. And again, so if the neighborhood is dissimilar, it contributes more highly. And if there is again income transfer from wealthy people to not so wealthy people, then ultimately we'll arrive at a scenario where the neighborhoods are equal and the spatial inequality index is also quite low. Now we apply this idea of spatial inequality index to like our case of school funding. So let's assume that these are the different schools and they are connected based on their geographical proximity. So there is an age. So we are basically forming a graph where the schools are the nodes and the edges denote whether two schools are close to each other. Now, as I mentioned, like for better management, we group these schools into different districts. So essentially, and these districts determine, so let's say here there are 4 school districts. So red, gray, blue, and purple. And different school districts get different amount of funding based on like what the governments provide, right? Like, so in this case, we can see that the red school district is much poorer compared to other school districts. So we apply this concept and we calculate the spatial inequality for different states. And again, we see that some states where there is very high spatial inequality. So for example, states like Colorado, Nevada, New Mexico, here there is very high spatial inequality. So in these states, there are school districts which are getting very low funding or less funding, and they are surrounded by school districts which get a lot more funding. And there are also states like Alabama or Vermont where the spatial inequality is lower. So there is a gradual spread from highly funded school districts to lowly funded school districts. Now, our idea is, can we redefine the school district boundaries? So what we have computed so far is on the existing school district boundaries, like whatever is there in the present scenario. But the whole idea is that, can we come up with a new district boundary so that the spatial inequality is lower? So going back to our example where we had this red school districts, gray school district, blue and purple. So this is the current existing school district boundaries. And what we are saying is that can we redraw them? So by moving one school from one district to another district, so that ultimately when we look at the per student funding, almost all are equal. So essentially, when we compute the special inequality index over this new school district boundaries, it should be much lower than what it is originally. Now, as you can guess, like this particular problem maps to a fair maps to a graph partitioning problem in computer science. So essentially, what we are saying is that we have different nodes and edges, and we want to partition the graph in a way that when we compare across different partitions, the average wealth or average property of that particular partition, it should be equal among the neighboring partitions. So that's basically the key computational problem which we are trying to solve. However, it turns out that this computational problem is an NP-hard problem. So, in fact, it is NP-complete problem. So, so that means that directly minimize spatial inequality is computationally hard. So, what we did in this work is we developed a greedy algorithm which starts from the existing grouping, although it can start from any arbitrary grouping, but in this particular context, we started from the existing district boundaries. We look at a particular neighborhood where the inequality is the highest, so which has the highest contribution to the overall inequality number. And we iteratively redistrict schools. So that means that we move one school from one district to another district to reduce the neighborhood inequality. And this we continue until we cannot improve the spatial inequality number, like we cannot lower the spatial inequality further. So this is a pretty standard approach, right? Nothing fancy here. But by applying this greedy algorithm, what we saw is that like we see dramatic decrease in spatial inequality number. So when we compare the before redistricting and after redistricting, we can see that across all the states, we have see huge improvement. The spatial inequality is much lower. So in fact, if we look at this effect on the district maps, so this is the map of Colorado before redistricting. So these are all the district boundaries which are current, and like different districts have different per student funding, and you can see that there are districts which are low funded, and they are surrounded by districts which are much highly funded than these districts. Now, when we look at the maps after redistricting, we can see that there is a kind of a gradual spread. So in all these cases, the most of the districts are similarly funded, and in other extremes, I mean, they're more funded, but again, like there is no like island as such. So this is more homogeneous scenario. Now, of course, when we look at the variance in different states, again, like going back to this box plots, we can see the variance has decreased quite a bit, and this is expected because this is something which we also saw in the spatial inequality index values. But most importantly, the question is that while we are doing this, because this was our objective, that we wanted to redesign or redraw the school district boundaries so that the spatial inequality becomes lower. The question is that by this process, do we end up making school districts which are like either too big or too small? So when we look at the number of schools in a district, we can see that before redistricting and after redistricting, they are mostly unchanged. So we don't change the number of schools which in a district, and rather we move one school from one district, add it to another district, and maybe move some other school from that district to this first one. So essentially, by just transferring or exchanging schools between different districts, we could lower the spatial inequality index without changing the administrative overhead much. So because otherwise what would happen is that if we create very large districts, this would add to the administrative overhead. However, another important thing is that the policymakers may want to have a control to just limit how much change is permitted, right? So in this plot, what we are showing is that, like, suppose that there was a threshold that only this much amount of schools can be redistricted, like this can be either like 25%, 50%, and 75%, and so on. We are showing how much would be the reduction in spatial inequality. Now, there are states where we might need a substantial changes. So unless we move 50% schools, or we kind of change 50% schools from one district to another, we don't see much reduction. But once this 50% threshold is crossed, we see that we can achieve both 25%, 50%, 75%, in fact 100% of the achieved reductions in spatial inequality within this range. However, there are also states where we might need minimal change. So just by moving 25% of the schools between different districts in West Virginia, we can achieve very like high reduction in spatial inequality. And there are, of course, states like Nevada where if we can achieve something by just moving only a few schools, but in order to get the best possible outcome, we may have to move many schools. So there the policymakers can just set a threshold that, okay, we don't allow much movement, but we are happy with whatever reduction in spatial inequality we can get. Now, just to summarize, so in this work, what we did was we look at the spatial notion of inequality, like how different neighbors are equal or unequal to each other. And this captures people's perception of inequality, because people don't really know the entire income distribution, or like what kind of benefits different people are getting in a very large area, for example. And they may care more about their immediate neighborhood. Now, to capture this, we introduced a new spatial inequality index. We proposed a practical algorithm to lower spatial inequality in school funding. However, importantly, this particular concept and this kind of algorithms can be applied in other scenarios. We just have to change the definition of neighborhood, like from a spatial geographical neighborhood to online neighborhood and so on. Now, the question is that, especially coming back to the school funding inequality, we propose a solution which is computationally feasible, but can it be actually applied practically? Now that there are some questions marks there, because in order to redraw school districts, there needs to be a community participation, there needs to be legal changes and so on, like which might or might not be feasible depending on how how the political establishments are interested. If they want to minimize spatial inequality, it is doable, but it requires much engagement with the actual stakeholders. Now, just to briefly give you an idea of like where we can even take it from there. So if our goal is to counter the inequality in public school funding, another option is not to look at the redrawing the school district boundary. Let's say the school district boundaries are as it is, but can we bank on online educational charities? That can we ask people to donate more to schools which lack funding and which may be which may benefit from generous donations. Now, in these works, like which were I have listed the works, and you can go and just read this if you are interested. So we look at educational charities and see whether the online charities are actually helping reduce the inequality in school funding, and whether we can design different nudges to nudge users to donate more to poorer schools. And in fact, the ideas which we present in these papers are encouraging. And interestingly, one of the educational charities called Donors Choose, they have already implemented ideas similar to ours, which now clearly tries to incentivize users or donors to donate more to poorer schools. Now, with that note, I conclude, and I'll be happy to take any questions which you may have. Thanks.
Thanks, Abhijnan. So are there any questions from the panelists? Okay, great. So we have two questions from the attendees. The first question is there a threshold in terms of distance to denote close or not close?
Yeah, so in this case, we used a 5-mile threshold. But this is just an arbitrary number, so one can select the thresholds depending on the content.
Okay. Yeah. So Professor Niloy, maybe you can go ahead.
Oh, thank you, Abhijnan, for the talk.
Yeah, thanks. Yeah.
So redistributing may have various administrative issues.
Right.
So some redistribution may be much more easier than others.
Yes. So one thing is that, like, how much, as I mentioned, I think the main important thing here is the political goal, right? So one thing is like whether there is a push from the top towards achieving more equitable distribution. Now, in this case, it may require many changes in the lower level. Like, you really need to change the school districts. Like, although it doesn't require you to move the schools physically, but it needs a complete administrative overhaul. Some other cases, it might not be that difficult if it is just about distribution of money. Like, at least how much money we can send directly to poor people, right? So right now, the governments are more inclined to just offer monetary benefit across the board, as we are seeing this in the post-COVID scenario. But going forward, we may need more targeted distribution, that like people who are not earning enough, they should get most of the benefit rather just doing it across the board. So maybe that is something which might be a little bit more easily doable.
Yeah. Thank you.
Yeah, thank you.
So Abhijnan, there is one more question from the attendee. So in the average funding versus percentage students graph that you have showed. So
this one.
Yeah, instead of looking funding as an absolute value, did you take a look at the value normalized with the total county spending or state federal GDP?
So we didn't look at the state federal GDP, but we tried to normalize based on the cost of living at that place. So that was the idea, but this is interesting. I think we can also look at the percent of GDP which is being spent on different like schools.
Yes. Yeah, and then there is another question. So are school districts constrained by congressional districts? Like, can one school district be in two congressional districts? And who controls the school district gerrymandering, like local, countries, or state level?
So this is currently done at a local level. So there is a local school district board which manages and which has representative from the local community members, as well as mainly this is from the city council, etc. But if there needs to be a change in the school district boundary, it has to be taken up at the state level, because sometimes one school district may actually cover multiple city councils and congressional districts and so on.
Okay, great. Yeah, so there is one, again, very interesting question. So what is the whole impact of this experiment? Like, to advise the policy makers to fund uniformly?
Yes, I think this is a bit more computational policy work, I would say, and this is just to show to policymakers that it is computationally feasible to do such redistricting. Now, I mean, so sometimes what happens, let me tell you. So for example, in India, Niti Aayog publishes a lot of working papers. Now, sometimes what happens is that, like, the actual platforms which should adhere to this guidelines, they say that, okay, some things are computationally not feasible. So for example, there are a lot of e-commerce policies, and there is always a back and forth between e-commerce companies and the government, and the companies say that, okay, this is not practically feasible. So the kind of work we are trying to do, including this work, is like we are trying to propose policies which are computationally feasible to do or practically feasible to do, so that the government can say to platforms, and in this case, the government can tell the government itself that this is doable. But in, let's say, some other context, the government can tell the intended platforms that, okay, I mean, these are computationally doable, so why don't you take up this? So that is the broad level goal of this kind of works.
Okay, and what is the need of defining school districts here?
So school districts are needed because of better management. So the thing is that many things. So for example, teacher recruitment, or sometimes like purchasing different resources in bulk. Like if they want to purchase, let's say, tablets. I mean, so all this financial management, and so basically any administrative job is handled at the school district level.
Okay.
Instead of just letting it be handled by the local school management committee, like this are handled at a bit higher level. So that is why the school districts are needed, and that is the whole idea behind forming the school districts in the US.
Okay, and we have a last question. And it is like, can we introduce a temporal criteria as well as partitioning in addition to the spatial criteria?
This is interesting. We have not thought about it, but I think we should and we can. Yeah, okay. Thanks for the question. Yeah, this is a very interesting idea.
Okay, and again, this question is from my side. What could be some interesting studies that we can do on Indian ecosystem? Very similar kind of studies, that one that you're describing now.
Right. I think so. One thing is that rather than schools, so right now here the focus was on education, but we can in fact look at, like, we have many districts, right? Like districts, and we can just look at like how different resources are being distributed across different districts within a state. So it can be, let's say, through the public distribution system, like ration, etc. Like, so it can be either based on like food grains or based on some other type of materials. One problem in India is that sometimes the data is not that readily available. But in case data is available which concerns this distribution of public goods, or at a government level how these distributions are being done, then this can be easily applied in the Indian scenario as well.
Okay.
Now, yeah, and of course, like so sometimes even in India, so there are also these concepts of like some districts are like real physical districts. So for example, let's say like Delhi has 5 physical districts. But there are also sometimes conceptual districts, like they call it, like sometimes called police district, like where a physical district can be divided into 2 or 3 police districts for better management. So in fact, like for this particular idea to be applied, we don't need a physical district to be changed, like where it may involve a lot of cost, expenditure, etc. We can even look at a logical level, like when we have some logical districts, how we can better create this district so that the distribution is more fair.
Okay. Yeah, thanks, Abhijnan. So any other question? Any questions from the panelists? Okay, so we have no more questions. Thanks, Abhijnan, for this wonderful talk, and also thanks for accepting our invite. So
no, thanks a lot for inviting me, and it was a pleasure talking to all of you.